Now let us understand a very important concept about gauge transformations. When we say the gauge transformation of the perturbation of a field, this is what we are interested in. We want to perform gauge transformations of perturbation of a field. This is what we are interested in. So we want to derive equations that relate the perturbation in one gauge to the perturbation in another gauge. That means if I have delta F caret in one gauge, in gauge 1, and delta F tilde in gauge 2, I want to find a relationship between delta F tilde and delta F caret. That by going from gauge 1 to gauge 2, how delta F tilde is related to delta F caret. And when we are performing this transformation, we are deriving the equations for this transformation, then we want to see how delta F tilde is related to delta F caret at one set of coordinates x alpha. So this is what we call gauge transformation. Gauge transformation is not transforming delta F caret, is not transforming the value of delta F from gauge 1 to gauge 2 at one point P. That is not gauge transformation. Gauge transformation does not mean that we are interested in knowing the transformation at one point P. Gauge transformation means that we are interested in knowing the values at one set of coordinates x alpha. Now you may say that we could define our transformation so that we transform the values at one point P. You may say that we could say that this is gauge transformation, that is transformations at one point P. But you cannot, you will not have any transformation at one point P. Why? Because the value of scalar at one point P does not vary from gauge to gauge. Which means if you take the density value at one point P in the background universe and measure the value of density at same point P in perturbed gauge, both values will be the same. So value of a scalar at one point P will be same as its value in gauge 1, will be same as its value in gauge 2. So to begin with, there is no perturbation at all. If we define our perturbations to be the difference in values at one point P, and there is no perturbation at all. But we do not define our perturbations like that. We define our perturbations so that we are looking at differences at the same set of coordinates, not at the same point P. For example, if our coordinate is 1, 0, 0, 0, then we are interested in knowing the values at 1, 0, 0, 0 in their own respective gauges. So this is a very important concept. So you can look at my notes on this website. All these are published on my website, mycosmicschool.com, and there you will find the course Cosmological Perturbation Theory. And the take-home message of this discussion is that in gauge transformations, we perform the transformations from one gauge to another gauge at the same set of coordinates, not at the same point. At the same point, scalar fields are the same. So there is no transformation to begin with. And we are out of business right from the beginning if we define the gauge transformation to be the transformation at the same point. So gauge transformation is not the transformation at the same point, but at the same set of coordinates. So be careful. So whenever we talk of gauge transformation, we mean 1000 coordinates in the background universe, 1000 coordinates in the gauge 1, 1000 coordinates in gauge 2. Whatever coordinates you take in background, same coordinates in gauge 1, same coordinates in gauge 2. And when you are doing that, then physical location of points will be different. Because if you take physical location of points to be the same, if you take one fixed point in four-dimensional space-time, then the value of coordinates will differ. But we are not doing that. We are not looking at one fixed location in four-dimensional space-time. We are looking at one fixed set of coordinates in four-dimensional space-time. When you are looking at one set of coordinates in each gauge, then the point will vary slightly. Because each gauge is very close to each other, there is a perturbation between the difference in coordinates. The difference in the coordinates of the two gauges is of first order. So the two gauges are very close to each other. The coordinates are very close to each other. And the physical points that you will obtain by keeping the coordinates same will also be very, very close to each other. But they will be different points. They will not be the same physical points. Coordinates will be the same. And that's what we call gauge transformation. Same coordinates, not the same points.